Our vocabulary word here is supplementary. We have a supplement theorem, but that's when we use, or when we know angle 1 and angle 2, or a couple angles are a linear pair. For when we know they're supplementary, all we do is just use the definition of supplementary angles. And if you go to your sheet or need to go to your sheet to see what your conclusion is, you can do that. But by now, I would say most of you are pretty comfortable saying, well, that means their measures add up to 180 degrees. And we actually have two sets that say that. Also, by this time, we've probably done a couple where we have the sums total to the same thing. So here they total 180. Well, then the sums are equal to each other. And what we're doing is we're replacing. I'll just rewrite one of those equations. You could use either one, but we're replacing, instead of saying it's equal to 180, 180 equals a couple things, so we can replace 180 with the other thing that it equals. We're replacing 180 with measure of angle 2 plus measure of angle 3, and that's replacement rule. And then before you know it, you're like, wait, I'm supposed to prove a relationship between 1 and 3, and I have an equation with both of them in it. Well, so that relationship should state the same thing I'm trying to prove if it's able to be proved. So everything else should kind of work itself out, which if you notice, what's left? Just a couple of measure of angle 2's. And we're just going to cancel that out, but it's not really canceling. We're subtracting measure of angle 2 from both sides. So you can show that if you want, minus measure of angle 2 minus measure of angle 2, but you don't necessarily have to. We just have to state our new statement here for step 4. And then justify it. So what says that you can subtract something from both sides and that 2 can just kind of disappear? A, P, E. Additive property of equality. Add or subtract something from both sides of an equation. And I didn't get lucky. I actually knew that I wanted angle 1 on the left and 3 on the right, so I picked the sum that had angle 1 in it to go first and replace the 180 with the second one. But if you didn't see that far ahead, that's okay. At this point, you could have used symmetric property of equality, S little YPE, switch the order, and it would have been just fine. And then you could have changed it to congruence. It's probably getting sick of me hearing me explain this if you watched a few of these videos, but I want to change. I need to state those congruent. I had one measure equal. If you know the measures of something are equal, you can say they're congruent. And a lot of things have tons of measures. So, you know, a triangle has a lot of different measures. To prove them congruent, you might have to show all those measures the same. But for an angle, there's only one measure. So by definition of congruency, you just have to show that one measure the same rather than a whole bunch of measures the same. And that's what it would mean to be congruent. And so that's just what congruency is. Definition of congruent angles. We've shown all the measures of the angle the same. The angles are congruent.